introducing a new and unique, first-of-a-kind combined heat and power system that incorporates several unique features never before seen in the combined heat and power marketplace. First, this is a big block V8 reciprocating engine that produces low-pressure steam from the engine jacket instead of high-temperature water. The other is that the engine operates without a throttle. It's always operating at full cycle. The engine CHP is integrated into a boiler system, resulting in no additional stack, meaning there's no additional air permit. Any permit needed is essentially involves an amendment to an existing boiler permit. And finally, the engine power is generated by an induction motor which provides DC current to a regenerative variable frequency drive that inputs into the grid unity power factor 3-phase power through a UL 1741 certified inverter. Natural gas is fed into the engine through a lambda controller into a standard IMCO mixer. The controller capable of controlling the air-fuel ratio to within 3,000 of a lambda. The engine is cooled with 230-degree boiler feed water, which is bypassed from boiler feed water pumps and directed and piped over here to the combined heat and power system, through which it's controlled by a valve to 15 gallons a minute, flowing through an oil cooler, maintaining oil temperature to between 230 and 240 degrees. The 240-degree water flows out of the oil cooler and into a series of distribution pipes which are tapped directly into the head, injecting water directly into the head jacket at or around where the exhaust valves are located. The design is essentially a reverse of the typical flow pattern through a big block V8 and maintains nuclear cooling within the engine, allowing wide open throttle operation without having any excessive valve seat temperatures. Water comes out of the engine block in the form of steam and water, passing through a marine manifold which cools the exhaust, collecting and flowing out of the engine in a combination of 15 psi steam and water with a quality of approximately 15%. Exhaust, which is cooled down to less than 1200 degrees, is fed through a Y connector where there's a lambda sensor providing feedback control to our air-fuel ratio controller, and then is passed through a series of off-the-shelf carb-certified catalysts, resulting in near zero NOx and slightly elevated CO. The exhaust is then passed through a muffler and then ducted directly into an industrial boiler, where the existing flame reburns any excess CO and hydrocarbons, resulting in near zero emissions. The engine exhaust supplementing boiler fuel. The engine is torquing a variable frequency driven controlled motor, resulting in DC power being transferred to a DC bus, which is then converted by a regenerative variable frequency drive into 3-phase 480 volt power. All temperatures are and pressures and flows are monitored and logged. The exhaust valve temperatures, seat temperatures are measured by embedded thermocouples in the valve seat metal. The exhaust temperatures are all monitored, providing diagnostic of engine operation. By virtue of its wide open throttle control, the engine set speed can be modified to any output by merely changing the speed, all within 5 seconds. By virtue of its wide open throttle operation, high temperature exhaust at near 0%, and its ebullient cooled engine water, the engine CHP provides a combined heat and power efficiency, or heat rate, at less than 4,100 BTUs per kilowatt hour, regardless of output. The regenerative variable frequency drive control at wide open throttle allows the combined heat and power system to provide nearly instantaneous load control, providing support to the California grid. The combined heat and power efficiency, providing CO2 emission reductions by virtue of its nearly 4,000 BTU less heat rate over grid supplied power.